Hello again, the same project, next day or part 2, let's call it. So it's looking like today we're gonna have a really nice autumn day, full of sunshine, just a few clouds in the sky. Hopefully I can finally realize how much power this 100 watts panel can deliver in a day like this. And I may say it's pretty chilly with a cold wind, and that will help for sure for a better harvesting. Let's go downstairs. So here we are, 10 minutes past 11, and let's see how the things are running here. Everything starts 4 hours ago. Not exactly charging, since the solar panel was on. So we have now like 6.05 amps, charging with 3.68 amps, almost 47 watts. That's nice. Let me see the battery. So we got 5.8 into the battery for now, and it's only 11. I'm charging constantly with almost 4 amps. My old ammeter can say that. Let's wait for the end of the day, hopefully for good weather. I'm really curious how much I can get from this little panel. 20 past 3 in the afternoon. Let's see how much production do we have here. So we got like 24.8 amps hour from the solar panel, went to 25.44 amps hour. So this is kind of strange to the batteries. I think, and that's for sure, there is a kind of calibration or something between this little one and the PWM 015. I don't really know which of them are okay, but I'll take my ammeter right now and check the numbers. So here I have my clamp meter. Let me see, let's go to this one first. We have 4.05 amps, almost the same like PWM. So I think PWM it's running okay. But now let me see the other one, 4.09, and this little one shows me now a 4.2 amps. Yeah, it's a very clear difference between these numbers here and this number. I'm talking about the amps, the instant current. So 4.03 turns to 4.2, 180 milliamps difference between the ammeters. So at the end of the test, I'll do a kind of mathematics, let's say, to have the right numbers. It's very clear, this one it's measuring with 180 milliamps or around, more than it should be. It's not so important as long as I have the numbers here, 316 watts hour until now, in 8 hours, almost 9 hours. I gained yesterday for a few seconds the instant power from the panel going up to 82 watts, and this is pretty okay for a homemade panel. I built it like 4 years ago and still running. That's funny. Okay, I'll be back at the end of the day. Okay, so here we are, 7:30 in the evening, at the end of the beautiful sunny day. So almost 12 hours of sunshine, or at least daylight, and I gain from the 100 watts panel 400 watts hour. This is beautiful, and that's 31.9 amp hours, and we have in the battery 32.38, but I have doubts about the accuracy of this ammeter. Anyway, it's pretty close, so there is a discrepancy of 180 milliamps difference in between. The point is that 400 watts, it's a pretty good harvest for a homemade panel Well, the next phase of this experiment will be to measure the internal consumption. I mean the energy needs, the power needs of this very classic basic PWM solar charge controller. There are a lot of controversy about this, so now I'm going to have a very clear idea about how much this one takes by the night. So it will be 10 hours or something of pure consumption, nothing else. So I'm going to use this meter, reset it to 0 of course, and connect it in between the battery and the charge controller. Okay, so now I'm measuring the power consumed by the solar charger itself, but it's so low that the machine can't read anything. And it's not only that, it's also the timer, the running time. It's not running because we have no current. Anyway, I'll let it hooked, and I'll use my multimeter just to measure the current this little charger needs. Okay, so I have my multimeter hooked in between the solar charger and the battery, and here we go. The charger it's on, we can see the LEDs running, and look there, 8.58 milliamps. That's nothing, almost nothing. So I don't think we are talking here about a power consumption or a losing of energy, not at all. It takes almost like a wall watch or something. Anyway, so I let this one hooked until morning, and we'll see, maybe we can have some results. Yeah, here we are again next morning after one night of just consuming, just standby. I may say that we got no results. The consume was so small, so low, that this ammeter couldn't take any measurements, but we can do some mathematics about this. So let's see about the consume of that little solar charge controller. We don't know the resistance, of course, but we know the amps. It was like 0.0085. That means 8.5 milliamps, and we know the volts, and let's say like 12.4, and we have like 0.1 watts per hour. And if you count that like let's say 24 hours times 0.1, so we have a total consume of 2.4 watts per 24 hours. That's almost nothing. A couple of LEDs running up, that's it. And as you can see, I have a new PWM. As you can see, I have a new pulse width modulation on the wall. This one also have the possibility to charge lithium batteries, and it have a display for different functions. Well, it's not so great, but at least it's charging well. Now I'm charging with, let's see, 13 amps, 13.5 amps, so this is good. The point is that I got nothing here about the charging currents or things like this. I can only change the menus for lithium and other things like this, you know, like floating kind of batteries. That's it, nothing special about this one. It's very cheap and simple. I had a review about this in a video before. Of course, this one is also enhanced with proper cooling, even a small fan behind here. Let me show you. You see the fan over there, and a temperature sensor is turning on only when a certain temperature it's up, but it's running very well at 13 amps. This is great. It's not even warm, and this is good. Okay, that's it for now, people. I'll be back soon with some news. Anyway, if it's worth to buy something like this and to use it for a small install 100 watts 150 watts panel, of course It's very cheap and is doing the job properly. Thank you for now. See you soon and don't forget to have fun. Bye bye.